Welcome to Maths with Bob. This is the 3-minute series on statistics. We're looking at hypothesis testing today, looking at two-sided tests. We're looking actually on inferences on the mean where the variance is known. You can see over here. Okay, now we're looking at the normal distribution. You can see here, coming from the standardized normal, which is 0, mean of 0, which is in the middle here, and the standard deviation of 1, which is also, obviously, we square that, we get the variance is 1 as well. Now, the problem basically is that we're looking at a sample size of, say, 50 coming from a population which has a variance which is known. You can see here, it's coming from mu, 16, which is a normal distribution where the mean is unknown. Now, the sample of 50 has a mean of 15.7, and we basically have to try and work out does this support the hypothesis that the mean of the population is 17, or is 15.7 too far away from 17, basically? So we have to look at the significant levels of 5% and 1% significant levels. Okay. So the first thing is we can see here we set up the test. The null hypothesis is, in fact, that the population's mean, mu, is actually 17, and the alternative hypothesis, H1, is that the actual mean of the population is not 17. Now, we have to use a statistic, which is the standardized one, which you can see here is Z equals X bar. The bar should be down a bit lower, minus mu, which is obviously the mean of the population. This is the mean of the sample, all over the standard deviation, this is of the population, all over, you can see here, the square root of n, which is the actual sample size, which you can see here is actually 50. Now, if we look at this, you can see here, this turns out to be about minus 2.298. Okay. Now, we're going to have a look at 5% and the 1% significant levels. These two values here are coming from the normal tables. Now, we would need to look at the normal tables to get these particular values. Okay, so what's actually happening is, well, you can see here our statistic is actually in between accepting, what should be accepting over here at a 5% level, and at 1% it's accepted. So it's actually within the confidence interval of the 1%, but it's not within the 5% level. You can see this is the negative tail and obviously two-sided, so the positive sections up here. So what happens is at the 5% significance level, we are going to reject the null hypothesis in that the mean value is actually too far away from 17 from our sample. However, if we widen it and basically drop our significance level, we are going to accept the null hypothesis. Okay. So we say that this is actually quite a significant result in that we are rejecting it. So in fact, really what we would be saying is the mean is actually too far away from the basically the population mean to accept that the mean population is in fact 17. If I reject it at this level here, it's called very significant, and the p-value, which is basically where it changes over from accepting to rejecting, in this case is about 2.2%. Okay, well, thank you very much for watching, and bye for now.